Well, hello, hello. Welcome to the Plasma Implementers call number 24. I did not think of anything to say about 24. It's a great number, generally speaking. Let's dive right into some implementation updates. So why don't we start with Matic?
Hey, sure. So we have been like writing a lot of tests. So a lot of housekeeping, like refactoring some code, a lot of tests, and making sure things are working the way we intend to. And other than that, something new that we have been thinking about is, we were just wondering if if some established apps had to come on Matic again. So we were just wondering, it's probably not, they would be working on Plasma with their entire thing in one go. So we think it could be like in a siloed manner. So let's say they want to move some functionality on Plasma and then slowly come entirely onto Plasma. So we were thinking, like, how do you make dApps interoperable between your Plasma chain and Ethereum? So we realized an important ingredient in this part was to like convey some state changes from Ethereum on the Plasma. So I'll give a very simple example. So let's say you're trading some NFTs, and that NFT has like ERC20 shares on it, so like fractional ownership. Okay. Now, when people are trading those fractional ownership shares, we just want to give some trading fees to the actual NFT owner. Okay, like a very simple use case. So how do you do this? So let's say if you wanted to trade those shares on Plasma, right? You still want to know who the owner of that NFT is to give them fees. Right? So we were thinking that if you could somehow convey to your Plasma chain that NFT owner was someone and they changed at this point, so now you can start giving fees to that person. So I think this is one thing where we want to convey state from Ethereum to Plasma. So, and also keeping it decentralized. So we were thinking that we could have something like a bridge in between, and it could be a generic bridge where people could say that, okay, when this event is emitted in this contract, then map it to Plasma in this contract, something like that. And because we also have a proof of stake layer in between our Plasma and Ethereum, so we were thinking we could actually secure this mirroring of the events with a proof of stake construction. So if, let's say, the person who is authorized to mirror events, if they don't do it in the right manner, we could go ahead with a predicate and like we could slash them on the root chain. So just some ideas around this one.
Cool. Yeah, we should talk about that a little bit more later. Peter, maybe updates?
Yeah, so from my side, updates that I still continue digging in different Plasma implementations. So now my basic focus on Plasma Cache, and I'm looking in details what Loom network is working on now and how we can improve Plasma Cache by implementing like two kind of snarks, like vertical snark. I name it like vertical snarks for exits, and horizontal snarks for data compression to not store a lot of data. And we need also to make coin exchange. So I just wondering, is there someone from Loom network is available or not? So as we discussed on previous call, guys from Crypto Economics Labs, did you contact with Loom network? No. No?
Georges? Yeah, I talked with former developer there.
Georges.
Yeah, Georges.
Yeah, we're still in touch with Georges, and I will discuss with him later these implementations. I'm just wondering about a coin exchange mechanism. I heard that Alex Vlasov said that there is some kind of coin exchange mechanism that they already implement, but I didn't find it. I would like to have a look on it, and probably we can bind it with the horizontal snarks and make a great data compression mechanism. So that's what I'm focusing on, and most probably that's the thing that I will do for the next few weeks. The other updates, so I still looking for other implementations. I got a call with Bharat, who proposed Quark Gluon Plasma, but and they say that it's like really released and live. But as I can see, it's just simple plasma, account-based plasma, and there is no solutions for exit games. They say that they have some BFT consensus and you can vote, but looks like not very stable. I would like to dig more about this. Maybe you know about this solution, but in my opinion, we need to go with some kind of plasma cache and UTXO based models. So I just asking you guys, maybe you know, and what's your opinion about account-based plasma, or definitely about leverage Quark Gluon plasma implementation? So it's like open question.
Yeah, well, so hi, Shashank here. So yeah, I'm from Leverage, and Bharat works with me there. So I can give you some inputs on this, but I think it might be better served to have the detailed conversation perhaps more offline, because obviously this is more of a generic plasma call, right? But I think what I can chime in is that the current state is we've got obviously everything spec'd out, right? And the spec is public, and you may have read that. We do have a live exchange. And the way to look at it is that we do have the essential mechanisms in place, but there is still more work to be done. Not every single bit in our spec has been implemented, which is what we've been heads down busy doing, right? So if you do, and the last part not to mention is that while there are some things which are open source and out there, because some of our plasma code is very intertwined with our exchange code, we had embarked on a mission to just separate it out cleanly and then open source everything. And as it happens with every team, because our primary focus is trying to build our stuff, that just hasn't happened. We thought that would happen 2 months back, and it did not completely happen. So we are on it, and you will see a lot more clean sort of framework-centric pieces out there in the future. But even before you get there, like I said, we can take this a bit offline. And I could drop some of my contact information on the floor here, and feel free to ping me after the call.
Yeah.
And we can certainly walk you through what's there. So,
yeah, perfect. Shashank, thank you very much for update. Yeah, so as Bharat says, I'm really looking forward to when you will open source your solution. And I check your white paper, and I have a question, so we can definitely discuss like some different kind exit games attacks that I know, and probably we can find something, and I can help you to protect them, or maybe you already has solution for that. Yes.
No, we'd love to talk and learn. I'm sure there are some new things that we'll find. So absolutely, we will ping after this. Okay.
So I will still continue to dig in different kind of plasma and try to hack them. So let's keep in touch. Perfect.
Of course.
So that's my updates.
So I'll jump in. So we are also building account-based plasma implementation, and over some last few weeks, we have given a lot of thought over token swap predicates, which means like exit games, such that the token swaps are plasma safe and things like that. So we can collaborate after the call and like have a discussion about the problems that we face.
Cool. Shashank, do you want to actually give an update on the leverage implementation?
Yeah, absolutely. You know what, the key is, like I was saying, we're still heads down. We want to make sure we get the, sort of the plasma aspects in place for derivatives. And I think I may have mentioned in the past, one of the tricky elements there, unlike standard trading or standard payments, is the concept of having positions, right? So you essentially have positions and they get repriced. So, in a centralized system that can be modeled easily. In a decentralized plasma world, it just has, newer constructs that need to be created without necessarily polluting the whole plasma model, right? So that's what we've been very busy with. We've made some good progress, and we do hope that we'll meet our timelines of, launching that later this year. I was in fact, thinking for the benefit of larger community, maybe the next one or the following call, I'll schedule a small section where I can walk through the technical aspects of what we have done and get some feedback as well. So maybe that's what I'll follow up, and we'll have something, maybe the next one or the following one.
Yeah, that's a really good idea. I think it would be awesome if we had like, a while, an actual presentation for different projects to show like what you've all done, because I'm sure we've learned so much. So that's a perfect idea.
And from my side, it's one personal request about exit games. So if you can maybe open just part of code about like how do you manage exit games, it will be super useful and interesting. Yeah. Thank you.
Fantastic. Yep, will do. Thank you.
Cool. Plasma group, Ben.
Sure. So Plasma Group, I'm sure Carl will dive into this more in a bit, but we've been coming off a big research high most recently. So implementation updates on our end are primarily designing a new client architecture, which will be much more generic and support the wonderful OVM. So I'm sure more on that, stay tuned, but that's been what we've been doing, actually moving away from research and into the world of reality and figuring out how to spec a reasonable way to build the client that does this. So yeah, I'd say that's our main implementation update.
The optimistic virtual machine. Anyway, Crypto Economics Lab, you want to talk?
So after reading PG's blog post on OVM, we studied it and tried to list up all the things we as in the second layer solution committee as a whole need to implement, and like things we have to cover around the design concept of OVM. And we are trying to write up a blog post that about something that we can focus on along with all the other research teams based on the concept of OVM. And let me share the screen. Do you guys see my screen here, like this post?
Mm-hmm.
So this is more like a concept-based to-do list of the implementation, necessarily developments based on the OVM design. And we decided that we are going to focus on things not necessarily in the center, but also things around it, like predicates, client, front end, these things. And coming up with this idea, we also tried to think of the specific implementation questions, what this client side and front end predicate. So if we got a time in this call, we hope to have a time to ask all these questions to you guys. And yeah, that's our update. Stop share. Yes.
Cool. Yeah, I mean, I want to talk about the OVM all day, so that hopefully we'll have more than enough time. No, Andy, do you have an update?
Yes. So from musical side, we're recently been pretty busy. So we refactor everything to our abstract layer design, which is more or less a predicate, so we can support upgrade for Misego in the future. And we're working hard to implement and refactor every of our MoVP stuff to there. And if everything goes well, we will be audited soon, I think. Yeah. So that's what we're basically pretty much doing now recently.
Cool. Great. So I know that one topic which we already dove into a little bit was the kind of relationship between the kind of plasma chains and Ethereum with the Matic, your design. So I'm actually curious if folks have thoughts on that. So just to see if I understand correctly, essentially what you're thinking is, how does the main chain Ethereum interactions affect the plasma chain state? And the one of those questions, what was the exact thing that you wanted? You wanted to pay fees based on ERC 721 token transfers, and those fees are in Plasma. Is that right?
So my exact example was, let's say you own an NFT and people can trade shares. Okay. which is like fractional ownership for that NFT. So, but whenever anyone trades those shares on Plasma, you should be given some fees, and your NFT is still on the main chain. Now, the tricky part is once you transfer your NFT to Ben, the fees start need to go into Ben.
Ah, I see.
Even on Plasma. So
interesting.
Okay. And the point about why the NFT needs to be on Ethereum is like simply because it might be listed on marketplaces and OpenSea basically. So we do not want like. Mm-hmm. So it might not always be possible to like get all the assets on Plasma immediately and then.
Ah, I see. You could make the. I'm curious if folks have thoughts, but I think that a way that like the OVM especially has kind of like reframed some of the thinking of Plasma is like. You can design any of these games and just generally predicates. You can design these games and all of the Ethereum is always correct. And so we can, like, you could make something where you can still send fees off of the, like in Plasma, but if the fees don't go to the correct recipient, then they're kind of invalidated. That's one thing that you can do. I wonder, have you thought about that? Those kinds of constructions, basically making the fees dependent on the owner of the NFT.
Yeah, we were thinking along those lines, but yeah, this is a fresh idea.
Okay, cool.
Mm-hmm. So we were thinking, like if you could bring state from Ethereum to Plasma. Mm-hmm. So Matic specifically has a POS layer in between. So there are some validators in between that have some stake on the main chain. So we were thinking we could probably leverage this layer. So whenever something happens on Ethereum, and given that this layer has been configured to convey it to Plasma. So when something happens, it will be conveyed to Plasma. And then accordingly, things will move. And how do you ensure that this movement of state was safe using a predicate?
Yeah, I think you could even do it directly by encoding that transference of funds like directly into an exit game. But there's definitely like we need to figure out a kind of like user-friendly way to do this more generally speaking. That makes sense. Cool. Any other thoughts on this topic, or should we move to the next? Peter, I know that you submitted some topics on the call for topics. It seemed like you got into them a little bit in your update, but I want to give you a chance to kind of mention anything you want to.
Yeah, so my current update is just I want to discuss like how we can improve Plasma Cache and make it ready. So, but I think one of the only one group that's working on Plasma Cache right now is Loom Network. Is it right? So, like
the like Piggy Plasma Group stuff and Crypto Economics Lab, that whole that is mostly Plasma Cache. It is, technically it is everything, right? It is all of layer 2, but it is definitely very much Plasma Cache. So I'd say like, I don't know the current status of Loom, but I know that the current status of this, Plasma Cache flow, cool stuff is very much it's some good stuff. I promise.
Yeah. So it's not, maybe it's not correct. Like, of course, it's also different kind of flavors, and I'm pretty sure that Snark-based solutions can be applied for Crypto Economics Lab solution and for Plasma Group as well. Actually, I'm just thinking about coin exchange mechanism that I mentioned before. I don't know, is it related? Maybe do you have some doubts how we can use it, like to make some contract that can receive coin with their long history and like give back the new coin with the fresh history? So is anybody working on this solution, like to eliminate all these long tails for the history of the coins? Or, for example, to exchange one coin to different one of coins. So I need for DEX solution, if we need to trade, I would like to implement like you can split your trades or orders with small slots and trade with a simple slots. And then we also need like exchanger that can split and combine coins and refresh the history as well. So just wondering if somebody working on this now to discuss it.
Indeed, people are. I just sent a architecture design idea of atomic swap predicate, which gives you these atomic swaps. That is one very good post by Crypto Economics Lab. I wonder if there's also a post on checkpointing, which is a way to basically give a coin a fresh history with one on-chain transaction. That is pretty nice. Here, I'll send another link. Rollup Plasma is useful in this as well.
Just send it to me. Maybe apply to our call, and I will do the future research and will give you feedback or maybe some code implementations and so on. Perfect.
Cool. Any other things on this topic?
So I think I'm fine. I would like to go deep in OVM and combine these ideas with DSL that I proposed on the previous Plasma call. So I think they will work together, so we can create like formal specification how to build these solutions.
Cool. I mean, I'm happy to talk about some OVM stuff. I feel like I've already been talking a lot. Like Ben, do you want to talk about OVM stuff? Or do people have other things that they want to talk about before we go into this, all these OVM things? I it seems like people want to do the OVM stuff, right?
We've got some question list already, so.
Okay, great. So maybe it would be good. I'll do maybe like 1 minute, just kind of super brief screen share that kind of just, this is, we put out this blog post. The long story short is that we realized that a lot of these like layer 2 solutions, what they're essentially doing is they are kind of doing this kind of thing called optimistic execution, where we're kind of changing the state of our system based on off-chain messages. So here, this is an on-chain, this is just a normal blockchain where we're, finalizing blocks and, building up a chain. And every time we finalize a new block, we get to a new state. That's really nice, right? But the problem is that we only change the state when we actually are, receive a new block and finalize it, which is, we've learned, very slow, right? You get like 15 transactions per second on Ethereum. But we like this concept where you can, have this off-chain data. They're sending each other this local information, and that is changing the state, in a state channel, or it's changing the plasma state. And so what we realize we can do is we can actually change this state using a kind of unified client, unified wallet that will be able to interpret, state channel solutions, plasma solutions, and not interpret them in a way that is a kind of like hacked together, combination of all of these different technologies, but instead is using a single language which describes all this stuff and actually makes it easier to plug in your, Plasma solution or your state channel solution. And so here we have the same kind of, future Ethereum states, but this time, instead of, transitioning when we go to a new block, we're actually transitioning the state machine every time we send an off-chain message. And that is essentially restricting possible future states. And this restriction of possible future states is essentially saying, in all future states, Alice received some amount of money, or in all future states, Bob received some amount of money. And this is the kind of like general concept for what we're doing with layer 2. And so we can actually use this plus a mathematical language based on, predicate logic, based on these kind of logical inferences and contradictions to express things like even zero confirmations, Lightning Network, cross-shard state schemes, plasma channels, TrueBit, including, gluon plasma and matic plasma and all these kinds of different solutions under a kind of shared mathematical framework, so that we can reason about it a little bit better, and we can like write and formally prove things about our plasma solutions. We also developed this universal dispute contract, which I definitely recommend y'all check out, where it basically has all of the possible dispute logic that you might create in a very kind of clean form. And it actually turns out you can boil all of these exit games down to claims, decisions, and contradictions. Anyway, but that would be a longer discussion, and maybe I'll hand it off to Ben. You want to talk about some OVM stuff, shed some light that I didn't? You can share your screen, by the way.
Yeah, well, I don't have much to share, so I guess I'll just talk a little bit. The thing that I would say for people who have read the post, who are interested in reading the post, is like there's two kind of distinct parts that I think are like important to separate. One of these is like the very broad language of how do we describe all of these solutions. And then the second part, which is like the contract and sort of the second half of the post that Carl was just looking at, that gets into like, once we realized what this language is, it made a lot more sense to us that we would want to build a contract in this way. And so basically, what I think our most exciting realization was that for a very broad class of layer 2s, so things like channels and plasmas, we realized that if we had predicates before for generalized plasma, now we have like real good predicates, because it seems like we can actually create the entire plasma exit game as a composition of predicates, as composing nested series of predicates. And so not only can you write a plasma exit game in this language, but you can write a state channel in this language. And so because of this, yeah, we're very excited, because it seems like a compelling way to build some sort of client that can be built once, and then you can develop more complex apps on top of it by sort of writing in this higher level language. So that's my spiel. Yes, Carl and I, we're all very excited. It'd be cool if folks had questions or whatever else.
So just one question, more forward-looking type. So are most of the specs looking at bringing in OVM as a core part of the sort of implementation? It certainly has caught the imagination of all of us, right? Like it's a good new design improvement, but is everyone kind of already en route to implementing it as a part of their core spec? It's more like an open question to see what everyone's doing. It certainly looks like Plasma Group folks, you guys are onto it, right? Like a little more detail. Right now you put your posts out and you're trying to figure out the next level of detail, if you may, right? The implementation.
Definitely. Yeah,
is everyone else also doing it? Because we've also read, but I think we've stopped at just reading at the moment, to be honest. We haven't done anything more than that. Man, silence. Yes or no?
The answer
silence
is
imply
yes.
yes or no?
The answer is yes. So we are definitely working on our, implementation of the OVM, and the kind of re-architecting a little bit of our core client code. And I believe Crypto Economics Lab. I'm curious what your status is, what you're working on. But this is definitely a big focus for us, and this definitely will exist. It needs to exist.
Cool.
As I stated in the status update before, we were just focusing on to clarify what would be needing to implement, what will be, what we should focus on to implement around OVM concept more, and like listing up all the questions we have to ask and all these towards the standardization of or various types of clients, and that would be suitable for any kind of second layer solutions. So regarding that, what would be like I'm asking PG folks, either Ben or Car, what would be like a specific plan for the OVM implementation regarding the standardization of the client? And
Well, we are actually working on, we just recently, like last week, got through a document which outlines a bunch of the kind of client designs and how to actually, redesign your, using the OVM techniques, how to design a client. And so I'll share my screen a little bit. Where we are essentially like, we have, using all of the same stuff for the contract, we have a kind of client-side mirror of the contract. And so I think we should probably publish this on plasma.build. But we have, a kind of some implementation, the beginnings of an implementation spec for things like state channels, coin ranges, and a number of things, including processing layer 1 events, which I actually don't know what's actually there. But anyway, the point is that we're definitely working on actually having a concrete implementation of this stuff, and specifications, so that everyone can basically start building this. Does that make sense?
Yes. So is there going to be a concrete universal decision contracts that can support any kind of, is that right?
Yes. Yeah. That's 100% right. We need, so there are a couple of things that would need to be implemented, and I'm just going to be very, the things that need to be implemented are the universal decision contract on the, on Ethereum. And so that basically means taking that document that we shared in the post at, excuse me, and writing that in Solidity. That will be really, really important. And that will allow us to then build all of these different dispute protocols. And instead of expressing them in a kind of like ad hoc language, we're able to express them in the mathematical foundation that they are kind of based in. And then the other piece is going to be the client software, where the client software should be kind of, it uses the same predicates, it evaluates the same kind of logic, or at least very similar. So, for all coins in this, coin ID's history, they have all been deprecated or they've all been spent, and the last one is not spent. That's the kind of logical equation that we want to be able to evaluate in both settings. And so this document kind of outlines a first pass of like how one might evaluate that in an efficient way on the client. And then we have, designs for, all of what the actual implementation of, for instance, Plasma, state channels, and a number of other things would be in this, using this language. And so we need to just release all this stuff, I think is really the takeaway.
Yeah, through researching your idea, we just wanted to make sure your primary goal of this proposing the new design idea is not just, it's not just an extension of Plasma, but also generic concept throughout the L2 system as a whole, right? Is that
Exactly.
correct?
Yeah, that's 100% correct. But Plasma is still the best L2. Anyway, Ben, you go.
Of course it is. Maybe an example of like some of the motivations that led us to this. We spent a lot of time trying to reason about state channels on top of Plasma, right? This is clearly an extremely compelling use case. But unfortunately, using like existing state channel frameworks, like within the context of like building it on top of a sort of, you know, like old Plasma sort of predicate, you know, as we define predicates before all this OVM stuff, that ended up being very challenging. So like we spent a lot, I don't want to say wasted, but we spent a lot of time trying to dissect how to take the specific details of the Plasma exit game and the specific details of one of, you know, several like state channel exit games that were out there and merge them together. And it seemed very hard. And now like what we've realized is that using this single client, like we'll be able to express both, and we don't have to really, you know, rewrite an entirely separate state channel client. But we also don't have to sort of, you know, create this Frankenstein monster of L2 solutions that are, you know, where we take a bunch of different, you know, code bases and SDKs and force them together.
What would be the other example that you guys wanted to integrate into this concept, other than state channel?
I would say that state channels are the biggest one, definitely. Beyond that, I mean, I think that well, one of the interesting papers and interesting projects that I think has been very Plasma-like is NoCust, if you guys are familiar with that. And so NoCust is the kind of thing that seems like very Plasma-y. You know, they call it a commit chain, right? And it's clear that they're using some of the same design decisions that Plasma does, and that they commit these block headers to Ethereum. And they, you know, they definitely go about it in a different way. But this would be another kind of thing where we can probably design a NoCust predicate and things like that. And just in general, like one of our reflections after building our testnet and then moving on to generalized Plasma is that these designs are constantly evolving, and like we need a way to not have to rewrite a client server architecture from the ground up every time we want to make, you know, change some of these decisions. So yeah, that would be another example. But honestly, I think channels in Plasma were the biggest one. And maybe another one also was swaps. So you guys just put out that great post, Cryptoeconomics Lab, on swaps, which is super awesome. And I've missed the chance to dive into it, but I really need to. But it seems possible that this will be a prime example of something that may be easier to talk about for swaps, because the exitability of the other coin that you're swapping with, you know, is describable as a predicate as well. So you don't have to you no longer have the swap predicate looking at the exit game, you know, maybe that's the idea, is that it will all be one exit game. So that was another conversation that got the OVM sort of in motion.
One other thing that is exciting about the OVM is it also can be used very effectively for basically a recreation of, you know, basically Ethereum, hilariously enough. So something that I actually have on the agenda that I just like threw in there at the very end is one of the hilarious and honestly quite probably useful things we can do with the OVM is we can embed Ethereum 1 inside of Ethereum 1. And so what this basically means is this is using optimistic rollup or Plasma rollup type techniques to essentially create it's almost like a better kind of true bit drive chain or shadow chain. It depends on what you call it, but essentially you put all the information that you would run to calculate the state on Ethereum, but you don't actually compute the state in layer 1, and instead you compute that state in layer 2. And so there's actually some pretty it's actually not so hard to do, and it can be done 100% with the universal decision contract. And so that is like that means that we'd kind of get we kind of can reframe in some ways even things that we would conventionally think of as layer 1 as a layer 2 OVM application, which I think is totally a notable and interesting finding, and potentially quite useful.
I have a little questions regarding the dispute things and claims. So I'm curious, if there's a dispute, there's a claim that's need to relies on another claims. How do we handle those kind of situation? Like you have to wait for another claims finalize the result, and your claims can be finalized. How do we actually do that in OVM?
Ben, you want to go?
Sure. Yeah, I can talk about that. This is certainly certainly a topic that needs to be fleshed out more, I would say. In general, like the idea of the OVM is like the notion of coin. That's not a part of the OVM. That's a specific application. See, so which is a little tongue-in-cheek way to say that since the exit game for those coins is built on top of the OVM as opposed to as the core part of this dispute contract, it depends on the nature of the dispute. In general, it seems like I will say that one of the things that Carl and I and the rest of the PG team have been finding as we explore this, for instance, something that we found when we were exploring the client designs, is that there's often multiple ways to express a claim, because you can logically prove that two different logical statements are really equivalent. So a trivial example of that is A and B is the same as B and A, right? And there are many other examples. So one of the simplest ways is that if this coin is going to be dependent on another coin, then you just simply AND the two, those two coins' properties together. But it might also be the case that you want to make them separately and give a predicate that can observe that the other one has been complete. I think that I think it depends, but it seems like the answer is you connect them with a predicate, which maybe is just an AND predicate.
Regarding that, I have a question. How do you notate concept of time with the OVM concept?
Good. That's a good question. Time in terms of dispute periods, or
order of those two exit you want to connect with, or AND predicates.
Interesting. So I haven't thought about that a lot. I don't think any of the initial contract designs that we put forward used a notion of time other than the base sort of dispute period. So that's a really interesting question, and we should totally chat about that more. I think that generally speaking, okay, so it depends. I don't know what you guys have. I'd be very curious your guys' thoughts on the atomic swap research you guys have been doing. But is this an example of where time is sort of related because these two exit games are tied? So one of the things that we found there seemed to be that you had a trade-off when you were doing atomic swaps between exiting all the coins in a series of atomic swaps at once and being able to withdraw within one time period, or having the risk of getting challenged and having to play out another dispute period later on. If that makes sense. That might be slightly hard to explain, but it seems like time and decisions are related, because sometimes you can't make a decision until a timeout has passed. And so therefore, if you have a decision that is dependent on another decision, and you don't want to, and you want to optimistically assert this decision, if you get challenged, then you might have to wait an extra dispute period to play the timeout on that decision. But it's possible if no one disputes you, you could get it out right away. So maybe that helps a little bit in terms of our intuitions for time.
We kind of thought of the same way.
Cool. Yeah, it seems like a you know, some sort of, it felt fundamental. I wish it wasn't, because then we could just make, you know, Plasma instant, but I think timeouts are here to stay.
Is there another question? Oh, create two.
Yeah, I want to ask you very small thing.
It might be like off topic, but things that maybe Carl just mentioned.
Maybe you will use create to object code for OVM predicate. Create to object code. I guess maybe universal decision contract has exit bond, like bond we need. So for example, very complex predicate and small predicate is should have the different bond, I guess.
Bond meaning
dispute bond.
Dispute bond.
Like exit bond. So how do we define exit bond of claim?
How do we define an exit bond of a claim?
Yeah.
So I would say that likely what will happen is there is a kind of, I mean, there are multiple ways to do this because it is a kind of Turing-complete language, but a way to do this that I think is reasonable is you think of the universal decision contract as the thing that is making the decisions, and that's basically it. And then if someone makes a claim that is, you know, an invalid claim, and you are, you know, an application that cares about that claim being, you know, always true, for instance, and if it's ever false, then, you know, there's some bond that is forfeit. Then there will be some, you know, external logic that is watching that decision making and says, oh no, a decision was made false. Let's, you know, slash this person, or let's, you know, send the bond to the other person. It is possible to kind of, one could imagine tightly coupling the bonds and the decision contract. But it seems like the decision contract's like scope in terms of what it's actually concerned with is very, very nice already. And so I think it's probably going to be like, you have other smart contracts which use the universal decision contract as a reference for what the truth is about more complex, about those claims. And you also mentioned something about create two. I think the general opinion on create two is like where we where we can avoid it, we do just for like gas savings. But it totally is a reasonable thing to use it is a reasonable thing to use.
Oh, thank you very much.
Maybe just to add briefly on the bond discussion, I think it's a very good one, and probably one that we haven't thought about very, very deeply. One thing that we have identified, though, is that it's definitely the case that you need a way to whitelist different kinds of claims, or have sort of different buckets of buckets of permissioning between these predicates. So for example, what we don't want someone to be able to claim is to claim, I claim the property which hashes to this value. Because if you don't know what the preimage to that hash is, if you don't know what's behind the hash, then you have no way of disputing it. So another way to say that is you only want to allow claims to which all possible implications are computable by the client. And so for some things that's very easy. For example, for like the ETH1 inside ETH1 thing that Carl was talking about, like it's like these claims are going to be binary, right? It's going to be, I claim that this data produces this state transition, and so on. For Plasma, you have to be able to enumerate every single possible previous block for those coins. But in general, there are like lots of other very weird sorts of predicate compositions that it doesn't seem like we want to allow. And so because of this, it seems like we want some sort of bucketing to say whitelist only this type of claim. So for instance, there's a Plasma property, and you have one contract that only allows you to submit claims through the Plasma property. So, and that would be also where you put the coins when you deposit into Plasma. So it seems possible that you could put bonds there as well. Anyway, that was a little lengthy, but yeah.
Yeah, and one good intuition, by the way, is that the decision contract, in the context of this decision contract, you have one decision contract, and then you have state channels, Plasma, ETH2 phase 2, all of these things. They are all kind of defined by a particular whitelist of claims and / properties, right? When you wanted to like define a new protocol, then what you'd do is you'd start defining new claims. But as an application developer, ideally we don't have application developers worrying so much about claims and exit games and all that kind of stuff. And instead what we can do is we can have a simple set of like, this is the state channel claim structure. This is the Plasma claim structure. This is the a global Ethereum state claim structure. And now what we can do is like as an application developer writes their application, they just plug and drag and drop. Okay, I want this feature I want this component for this feature. And then as a user, they have a single wallet. And that wallet is running the OVM and doing these computations, making sure that the applications they're interacting with are safe. And then, we get this kind of single environment in which users can interact. And that kind of gets over some of these like really tricky problems with Plasma, where it's like, okay, how does it interact with Ethereum? How does it interact with other Plasma chains? How do we get people to deposit into a wallet when there's like a 7-day exit period? It's a real pain. So hopefully some of these issues can be addressed. That was a little lengthy too, but.
Yeah, because I asked a question. So speaking of like interaction between Plasma and EVM, like how does the OVM interact with the EVM states? For example, like in Plasma MVP styles, there's a priority queue. Like should the priority queue state be part of the OVM, or should the priority queue be part of EVM?
Great question. So the OVM is almost like a wrapper on top of the EVM and on top of other virtual machines that kind of runs everything in a single, virtual environment. So the way to think about it is you still have the priority exit queue of Plasma MVP running in the EVM, running on top of Ethereum. But now the OVM is, checking to see the state of that queue, checking it against its off-chain, decision-making logic, right? And then figuring out, oh, okay, I need to exit my coin now because there's an invalid, exit going through, and we all need to get out of this chain, for instance. And so that's, this is definitely a, so it's a layer on top. That generalizes a large class of layer 2 systems. In fact, probably any layer 2 system that I'm currently aware of.
Got it.
In particular, one way to think about it is that the priority queue in MVP should be expressed as an ordered sum. So when everyone is submitting like exits in MVP, really what they're doing as we build up this queue is everyone's claiming that I am within the first, deposited amount of UTXOs that is unspent. And the way that we disprove exits at the end, so the way that we invalidate claims at the end, is we add up all the earlier claims and we show that in total is equal to the amount deposited. And so the way to express MVP in the OVM is to talk about it as a sum, an ordered sum.
Yeah, so I was thinking about that way as well, but then that it sort of brings like the second claims need to kind of monitor the first claim. Is it true, or like you have to your next like whatever new claims comes in, you have to keep tracking all the previous things working on, and how does it work? Like, and now times comes in issue. Like, I don't know how the dispute time would actually interact, because like you have to exit with the priority there, but the claims might not be start with the same priority. So your dispute timing would be different from the priorities that the priority queue promises you. So I don't know how should I implement that, as I have no picture there, so that's why I'm really confusing at that part. Yeah.
It's a good question, I think that like again the trickiness, like one of the tricky things that we found is that there's usually several ways to like logically express one statement. And so you are right in that the priority queue things are sort of talking to each other. And it's possible even that requires some custom stuff specific for MVP. So like one of the things, one other example of this is in cash flow, when we have this interval tree, the sort of exclusion proofs, the things that prove like if this was included here, then nothing else could have been, is like is one example of like a slight addition that you have to make to the core OVM to get it to recognize. Because unless you implement a Merkle tree, or a Merkle interval tree, OVM plugin, you need to, it's impossible for the client to understand that. So it's possible that the interactivity in MVP would require some small addition that maintains this queue, and it's basically like each step in the queue is an addition.
I see. So it's more or less like OVM would be holding the main standard way, but there are some exceptions actually. Like it's probably very, very hard to be expressed as an OVM style. So in that, for those cases, you'll be like a predefined stuff in your like client and OVM. Is I understanding correctly, or?
Close. I would say that in fact, it is still within the purview of the OVM. Mm-hmm. The key thing is that for particular decisions and for particular claims, right? So a claim is made up of all of these like sub-claims, right? And these sub-decisions. And so at the very lowest level, right, you're going to have like, and this claim, and for all of these claims, right, there's like these standard claims. But then at the very bottom level, you have a decision which needs to be made on, is the priority queue, elapsed, or is there, is an exclusion proof shown? And at that very bottom level, you may need to write a custom, essentially like decider, predicate, whatever you might want to call it, that will like work for your particular application. And so that's essentially kind of like an add-on to what the OVM's, logic can interpret. So you do have to write something custom, but that something custom is just the secret sauce of your application, and then you compose everything else together. So you're still getting the kind of it's kind of like adding a plugin to the OVM as opposed to sidestepping the OVM entirely.
I see.
And another example of this is if you have a custom block structure, you're always going to have to implement that custom block structure, right? You're never going to magically have the OVM interpret blocks correctly. You always have to make it do the hashes in Solidity the way that you want.
Great example, yeah.
Yeah, I think that's a really good example, yeah.
All right, any other questions or things people want to talk about? We're already a little over time, which is, always a good sign. All right, well, that was a lot of fun. Thank you everyone for joining today, and I'm very much looking forward to talking to y'all soon. We should talk about everyone's implementations and all of your struggles. I would love to see like a presentation submitted by one of y'all that kind of just goes over what goes through your implementation. Why not, right? And like says all the status, like a kind of in-depth status update. I think that would be a lot of fun. So